Hello, 3 designers. This is Joshua St. John, 3Design NYC on the forum, and welcome to another installment of the video demonstration series. Today's demonstration is called Solid Module Fundamentals, Sweeps 1, 2, 3. We've got a lot to cover, so let's hop straight into the program. So let's talk sweeping. Sweeping is a staple solid modeling concept, and you will find the sweeping function that we're going to go over today under the construct toolbar to the right of revolve. It's called curve sweeping. So curve sweeping is pretty involved, so I'm just going to hop right in and show you a single path sweep. I'm going to create a sketch on the front view plane and plop a ring size 6 right in the center. And then I'm going to draw a cross section that is 2 by 4. Perfect. And I do have my grid snaps on now, just for your reference. I am also going to draw a NURBS curve, just kind of a squiggly line across the top that I will use to demonstrate in a little bit. I'm going to hide that for the time being and leave the sketch and go into the solid module. Okay, so sweeps are all made up of path curves, which you can think of as a railroad track, and then the sections, which you can think of as the railroad cars traveling along the track. So the first thing I'm going to do is select what is going to be my track or my path curve, and then click on sweeping. That pre-selects it under paths. You'll see inside the sweep function I have 3 tabs: paths, sections, and section orientation. So I'll click on sections, and I'll click the hand, and I'll choose the first section. And you see it positions it all along the path curve. Now the second tab down here automatically defaults to 0. So I'm going to hide my axes and planes. So you see the yellow curve is the cross section I've placed, and all the black curves are interpolations of that. So I could change the position to any of these like so. And I could have many cross sections. You're not limited on how many cross sections you have. You're only limited by how those cross sections relate to each other. And we'll get to that later. Okay, so I'm going to put this back up at 0. Like that. And we'll look at what else we have here. Precise I'm going to get to in a second. We're going to leave that alone for now. And we're going to go to section orientation. So first of all, we have effect, and that twists the cross-section along the path. In this case, we'll just leave it at normal. And then we have the alignment choices. We have top alignment, bottom alignment, left, and right. So we're going to leave it in the middle and top, and we hit preview so you can see. And then we'll go ahead and validate and just show you what that looks like. Now, perfect. It's a ring. Okay, so I'm going to hide that for a second, and I'm going to show that first curve, and I'm going to make another sweep along this curve. Choosing the same section, I'm going to rotate it 90 in this case, and I'm going to validate. Now, if you notice, the sweep is not a consistent thickness. And this is because the amount of cross-sections that are in it. And the cross-sections are directly tied to the control points. If you notice there, there, there. If I go back into the sweep, my sections line up with the control points. So here's where precise comes in. If I click on precise, it's going to create a sweep that is exactly this thickness. But if you notice here, we are running into some problems with the cross sections conflicting with one another, and that's due to the nature of this curve being so steep. So let's validate and see if we get an error. And you see we get the error. The operation failed. If I click back on the curve and I was just to decrease that and recompute, that should pass the test. Now none of the cross sections are conflicting. So when you see that exclamation point coming telling you that the sweep failed, it has to do with the fact that some of your curves are so extreme. And there are ways to make that sweep work or to make a shape like that. You just don't go about it this way. I just wanted to show you precise and what that did because it isn't really applicable in the ring example that I'm going to use. So that's a single rail sweep, and that's where precise comes in. So I'm going to delete that and delete that and go back to my ring example. I'm going to show the side view plane like so, and I'm going to cut and delete, keeping this side, and validate. All right, so now this face is exactly equal to this cross section. The cross section on a single rail sweep is completely defined by the size you draw it in the sketch. So if I wanted to make it 4x4, I change it to 4x4 in the sketch, and then I'm going to have a sweep that's 4x4. So that's kind of the basics with single rail sweep. I'm going to delete that cut and delete that I made. No, I don't need to retrieve. And I'm going to jump right in and show you two rail sweep. Now a two rail sweep, I'm going to take this ring size, which will be one of my rails, or one of my paths, and I'm going to pull it out to, let's say, 2 on the Z. Okay? And I'm going to leave the sketch to show the rest of my planes. Just, I don't need the top view plane. And I'm going to take this curve and I'm going to mirror it across the front view plane. Like that. And validate. Now there's a reason I mirror it in 3D instead of mirroring it in the sketch, and I'll cover that in depth when I get to 3-rail sweeps here in a second. Okay, so the order in which I select the paths doesn't matter. I can go 1, 2, choose sweep, and then choose the cross section. Have it line up on the bottom, and we can validate. Okay, so now this is the exact same. It's 4x4. Now, what does the second rail do? Well, watch this. If I take the rail and I move it on the Z, let's move it out to, I don't know, 8, and validate. Leave the sketch, and when I recompute, you see, now the cross section has been scaled to the distance the paths are apart. So it's going to be 16 by 4. Now, this, the up and down, doesn't scale at all. It's exactly the same distance as it is in the sketch. For instance, if I change this to 2 and recompute, now my sweep is 16 by 2. Show you, I'll extract this curve right there, and you'll see it's 2 millimeters in length. So two path sweeps scale the cross section between the two paths. Let me undo this and look to see if there's anything else I want to talk about in a two-path sweep. I do want to touch on scale on height, so I'm going to do one more quick example. I'm going to delete everything I've done so far, and I'll make a sketch on the top view plane. Showing it, and a sketch. Let's make sure my grid snaps are on. They are, and I'm going to use the NURB tool, and I'm going to draw kind of the outline of a leaf for a flower petal. The first side with 3 points, the next side with 4 points. Now I'll go and refine that a little bit, like so. And perfect. Now I'm going to draw the cross section. 1, 2, 3, like this. And I'll leave the sketch. So now I have 3 curves drawn. This will be my path 1. This will be my path 2. You notice they come together at the end. That's fine. I'm going to select sweep. The directions are going the same. That's good. And I'm going to choose my cross section. Now if you notice, they're kind of going off at an angle. This is where path auto orientation comes in. In path auto orientation, it's rebuilding the curves to have the same number of control points. So if I change that to 15, it comes like this. And I can validate. And I end up with this kind of chunky looking flower petal. I'm going to double click back on and show you the last option that I want to touch on. It's called scale on height. So if I click on scale on height and I validate, it's now going to scale the cross sections based on the distance the curves, the path curves are apart from each other. So in this example, that gives a really nice effect, and it's just the type of flower petal that I want. Again, I can change the effect to 180, flip it upside down. I'll do a bend to it, like that. And now I'll just do a quick circular duplication to show you the flower. I select the axis and the flower, then change the number to, let's say, 5. And validate. Okay, so it's not perfect on the bottom. I could play with it, but you get the idea. To recap, scale on height. That is a way of scaling the cross-section based on the distance of the paths in a 2-rail sweep. So now we're going to hop into one of my favorite functions in 3Design, the 3-rail sweep.